All right, good morning, students, or afternoon, depending on when you are looking at this. Today we are going to talk about messy trinomials. Now, the reason they're called messy is because when Miss Mackenzie writes on the board, it looks messy. All right, very sorry about that, but hopefully by now you're getting kind of used to it. So just a reminder of how expanding and factoring are just processes of manipulation for working with trinomials. So back in the day, you would have practiced multiplying the first with the first. So 2x times 3x equals 6x squared. 2x times 1 is plus 2x, and then you would do the second term with everything in the second bracket. So 3 times 3x is 9x, and 3 times 1 is positive 3. And then you would have a second step because you have two like terms, and you would group them together. So you would rewrite this expression out as 6x squared, and then 2x plus 9x is 11x, and then the other term is a positive 3, and then you are done. We call the process that we just did, that should say plus 3, not 13, my apologies. The process of going from the top to the bottom there is what we call expanding. So you would have been told to expand. And the process that we use to expand is called distributive law, and we use distributive principles or arrow method or FOIL, whatever you want to call it. Okay, so what we're going to work on today is going the opposite way. So manipulating this expression back into its factored form. And we call this factoring. So we're going to factor this expression, which is a trinomial, because there's 3 terms, back into 2 multiplying binomials in their factor brackets. Now, to do that, we're going to use a process called decomposition. In a separate video, I will go over what's called box method. About 60% of my Math 10 students preferred decomp and about 40 preferred box method. So it's about a 60-40 split. So I will provide a short video on that as well for those of you who prefer that method. Okay. There's also something called a crisscross method that you might have learned. I don't particularly care what method you use as long as you know one of those methods and know it well. All right, so if you notice in these messy trinomials, the number in the A position is not a 1, which means we can't use that product sum magic numbers method that we used in the previous video in the previous lesson. So here we need to take this 2 and we need to multiply it by the -1, and that's going to give us -2. So we're looking for 2 numbers that are going to multiply to -2. That has a 2 up there. It doesn't look like 1, but it is. And those same 2 numbers have to add to the coefficient in that middle term. So remember, if there is no number there, there is a number there. We're just too lazy to write it. So that number is a positive 1. Okay, so we're looking for 2 numbers that multiply to -2 and add to positive 1. Because the product is a negative, that means one of them is going to be negative and the other is going to be positive because they have a negative product. And when they add to a positive number, it means the larger of the 2 is going to be the positive number. So 2, the number 2, regardless of its sign, only has 2 factors, 2 and 1. So the 2 in that case has to be the positive 1. And 1 has to be the -1. And we double check, is -1 times positive 2, -2? Yes. And is -1 plus 2, positive 1? Yes. So with decomp method, we're going to rewrite this out, but instead of writing that middle term, we're going to decompose it into these 2 magic numbers that we found. All right, so I'm going to rewrite that as 2x squared plus 2x plus 1x minus 1. Now, just because I didn't put the x's in with over here doesn't mean that there weren't x's involved. I just find that kind of muddies the water and confuses things just to focus on the numbers. But when you use the decomp method, you have to remember that it's that middle term that's actually breaking up into the middle numbers. So you have to include the x's with it, all right? Because 2x plus, it should be minus 1x is going to give you that positive 1x. So they were the terms that were grouped together. Okay, it doesn't matter which order you put those middle two terms in. You could have written, instead of plus 2x minus 1x, you could have written minus 1x plus 2x. The order of which you write those two middle terms doesn't matter as long as you write them in the middle. So then you're going to focus on just factoring the first two terms because there's nothing common. There's no common factor with all four terms. All right, and you look at what is common between 2x squared and 2x. And the answer is the greatest common factor with those two terms is 2x. So that is divided from both of those terms, and you're left with x plus 1. Remember, 2x divided by 2x is not 0, it's 1. All right, then we go to the next one. And, little tip, whatever symbol is here is the symbol that you want to have here, okay? If you use the wrong symbol, you're going to have the next step kind of tell you that you didn't do it right, and you go back and you change the symbol. Now, the only thing common between negative 1x and negative 1 is negative 1. So if you divide both these two terms by negative 1, you're left with positive x plus 1. Okay, and you know you did this right because what's in the brackets is the same. If they're not the same, you messed up somewhere. Go back and see, did you use the right symbol? Did you use the right magic numbers? Okay. Now we have two giant terms, this behemoth right here and this behemoth right here. But they both have something in common. Their common factor is what's in the bracket and conveniently what's already highlighted in yellow. So x plus 1 is divided from both those massive terms, and you put in the other bracket what is left. So if I divide that first term by x plus 1, I'm left with 2x. So I put a 2x here. If that second term is divided by x plus 1, I'm left with negative 1. So that negative 1 goes here. And I have successfully factored that messy trinomial. Now there is an extra step I skipped over, well actually extra 2 steps. The first step is you always check to ensure that the trinomial you start out with can't be reduced in some way. That's something we covered in the last video. And the next step is you always double check that these factors can't be simplified further. Right? We're going to go over some examples where that happens, but right now we're just going to focus on using decomp to factor those messy trinomials. So then because you're finished, and you really like your math teacher and you want them to see your answers, you can put a little rectangular box around your answer so we can find it amongst all that work. Okay, so pause the video now and try the next one. All right, so hopefully it went well. The first thing you do is need to find your magic numbers, regardless of whether you're doing decomp method or you're doing box method, you need to do this step. So the first thing is to find out what these magic numbers are. So 6 times 6 is 36. So you're looking for two numbers that multiply to positive 36. And those same two numbers need to add to negative 13. So whatever this middle term is, including the sign that directly precedes it, is what the sum has to be. All right, so if you're not sure what those numbers are right away, you can always take 36 and go through all the factor pairs. So we have a product that is positive, which means they both have to be positive or they both have to be negative. But because there's a negative sum, it means we're dealing with two negative numbers. When added together, will combine to make 13, negative 13. So we're going to make all the factor pairs of 36. So 1 times 36 is 36. 2 times 18 is 36. 3 times 12 is 36. 4 times 9 is 36. 5 doesn't go into 36, and 6 goes into 36 6 times. And you know you've got all the pairs, the whole number pairs that multiply into 36, because the next number would be a 7, and that's, you've already covered that side of the right-hand side of those factor pairs. I'm pointing at it, which does you no good because you can't see me pointing, but hopefully you got that. So we're looking for the two pairs that add up to 13. And here we go, 9 and 4 are your lovely magic numbers. So it's going to be -4 and -9 because they add to a negative number and they multiply to a positive number. So we're going to rewrite this term, or this expression, sorry, but instead of writing the middle term, we're going to split it up into two terms because those two terms got combined. So do you remember how when we did this earlier step, we did this and we combined them to make that positive 11x. Now we're just doing the opposite. We're literally going in reverse. We are uncombining that middle term into the two numbers, and we found the two numbers by using this magic number system. So it's going to be -4x minus 9x plus 6. Okay, and then we are going to factor the first two terms. So the common factor between 6x squared and -4 is positive 2x. And if we divide that into both of those terms, we are left with 3x minus 2. Okay. And then again, for the second part, we use whatever symbols here and we copy that down. So it's going to be a negative. And the common factor between 9x and 6 is 3. So if we divide -9x and positive 6 by -3, we are left with positive 3x minus 2, because 6 divided by -3 is -2. Okay, and we know we did it right because, ooh, look at that. Look at the magic that just occurred. You have the same thing in both these brackets. So you have these two large behemoth terms. The first one is 2x times 3x minus 2, and the second term is -3 times 3x minus 2. And those two terms have the same thing in common. They have a common factor, and their common factor is 3x minus 2. And if you divided both terms by 3x minus 2, you would be left with 2x minus 3. Now, there is an easy way to check to see if you're right. So if you can't ask me and you can't ask Bob, or if you are in the middle of something, you're not quite sure if you did it right, there is something that you can do really quickly. Okay, and I'm just going to show it on a different screen so that's not too messy on the same screen. And I've already forgotten what my numbers are, so oops, let's go back here for a second. All right, I can't even ask one of you to remember for me. 3x minus 2. Times 2x, oh, brain doesn't remember very good. 2x minus 3. Okay, that's what we got as our answer. So if we were to use arrow method and redistribute and re-expand, we should get the same thing because we're not changing the value of this expression at all. We're just manipulating it. Remember, math is all about being master manipulators. Okay, it's the only time when it's good to be a manipulator in life. All right, 3x times 2x is 6x. 3x times -3 is -9x. -2 times positive 2x is -4x. And -2 times -3 is -6. And that doesn't look like the expression you start out with, but you haven't finished because you haven't grouped these like terms in the middle, and now you can because they are both terms with just one x. Oops, that was supposed to be 6x squared. And so then we get 6x squared minus 13x minus 6. And is that the same expression we started out with? Is that the same thing that we see right here? Yes, it is. So we get to pat ourselves on the back, feel all good about ourselves. Okay. So the next thing that we're going to look at are these ones right here. Now, remember how I said I kind of skipped over a couple of intro steps, and that's always to make sure that you can't factor something out first. Okay, so if you can, you're going to do that because it makes it a smaller trinomial that you have to deal with and smaller numbers that you have to find products and sums for. So if you look at 30, you look at 52xy, and you look at 16y squared, none of those three terms have the same variables in it all the time. So you can't reduce the variables, but what you can reduce is the numbers because they're all even, which means they're all divisible by 2. So if you divide them all by 2, you're left with 15x squared plus 26xy plus 8y squared. Now, some of you might be freaking out that there's a y in there, but please take a deep breath in, deep breath out. It's not really going to change how we're going to handle this, okay? So what we're first going to do is we're still going to find our magic numbers, and it's going to get a wee bit messy in here because I'm going to write over stuff. So we need to find two numbers that will multiply to what 15 times 8 multiplies to, which is 120. So we're looking for two numbers that multiply to 120. Sorry, I kind of wrote that one out too big and I'm not going to redo it. All right, so, and those same two numbers have to add to that middle coefficient of the middle term, which is 26. Okay, if you're not quite sure what that is, take 120 and write out every single factor pair for it if you need to. So you take out 120 and you just do your factor pair. So 1 times 120 is 120. And 2 times 60 is 120. And 3 times 40 is 120. And 4 times 30 is 120. And 5 times 24 is 120. And 6 times 20 is 120. And I'm going to stop there because 6 plus 20 is 26. Yay! So what you're going to do is exactly the same as what you did before. Now, technically, there is a 2 here, so you're not going to forget that it exists, but you're kind of just going to push it off to the side and leave it there. And you're just going to focus on working with what's in the brackets and factoring that. So you're going to rewrite it as 15x squared plus 6. Now, remember, whatever the variables are in this middle term are the variables you break up that middle term with. So we found our magic numbers to be 6 and 20. So that 26xy is going to be 6xy plus 20xy. And then it's going to be plus 8y squared. I'm running out of room. All right, so now you're going to do what we did before. You're going to look at just these two terms, okay? And those two terms have something in common, and it is a 3 and an x. So 15x squared divided by 3x is 5x. And 6 divided by 3 is positive 2. X divided by x is 1, and you're left with just a y. And you're going to do the same thing for the second two terms, remembering that this symbol is the symbol that goes down here. And the number that goes into 20 and 4, the largest number is 4. Okay. And the variable that is common between both those two terms is a y. All right, so 20 divided by 4 is 5. The x remains, but the y gets canceled out because it got divided out. 8y squared divided by 4y is going to give you positive 2y. And look at that, we have the same thing in both the brackets, so that's going to be the common factor that we divide out from both those two massive terms. And what's left are basically what's in front of those brackets, which is a 3y plus a 4y. And if you want to check to see how right you are, you can do the foiling arrow method, but we're not done because we can't forget that there was a 2 this whole entire time. There was this 2. Do you remember this 2 being here? So all we do is at the end we have to remember to put that 2 in there. Okay, and now that is our final answer. So to check that we're right, we would still FOIL those two terms, those two things in red. We would multiply everything in the first bracket by everything in the second bracket. We would group our like terms, and then we would multiply everything by 2. You can try that now. Make sure we're right. And you can also pause the video and try example 2b, and then join us back when we go over it. All right, welcome back. So this next one, this last one, we are going to, first of all, always look to see, can we factor something out? And in this term, yes, we can. There is 3 that is common between everything. And there's also an x. So we're going to be left with 3x. We're going to divide 3x from every single term, and it's going to be left with 12x squared plus 5x minus 2. Okay. Now we're going to find our 2 magic numbers, just like we were doing before. And I'm just going to do them really small up here. So it's going to be 12 times negative 2, which is negative 24. So we need 2 numbers that also multiply to negative 24. And those same 2 numbers must also add to this middle coefficient on the middle term. Okay. So pause the video here, see if you can figure out what those numbers are. So the numbers are 8 and negative 3. So we're going to rewrite this expression, not forgetting that there's a 3x here, but just kind of leaving it off to the side again. And we're going to rewrite this as positive 8x and negative 3x minus 2. Again, we're going to factor the first 2 terms, and the common thing from both of those is 4x, leaving us with 3x plus 2. And the second one, the only thing common between those, there's nothing common. But what can divide into anything at any point in time? That's 1. So remembering that we always use that symbol, so it's going to be a negative 1, and it leaves us with a positive 3x plus 2. So those 2 mega terms have 3x plus 2 in common, and if we divide both those mega terms by 3x plus 2, we're left with 4x minus 1. And the last step is not to forget this 3x that was on the outside. And because you really want me to see your fabulous work and find your answers, put a nice like rectangular box around it. Okay, so just to review what we did, we followed the first step. So the first thing you're always going to do is factor out any greatest common factor if possible. Factor greatest common factor out. Okay, you're then going to find your magic numbers. Okay, you're then going to factor by grouping, which is also known as decomposition method. So you're going to use factor by decomp or box method. And the last thing, you're going to check by expanding, which I showed you with one of those questions. Okay, so hopefully you have the explanations you need to finish that lesson 3 section of the handout. Please let me know if you have any questions. I hope you're all doing well. Thank you for joining me and have a wonderful day.